So today we're going to talk about erosion that is caused either by glaciers or by the wind. Now remember that erosion is the movement of sediments, stuff, by water or wind with the help of gravity. So here we go. Here we've got a glacier coming downhill, and we know what a glacier is. It's a large collection of water. It just happens to be frozen, and it is moving. We know that glaciers, by definition, are moving somewhere. So this glacier is moving down this hill. And as it moves, it's moving water. It can move stuff. Ergo, a glacier can then cause erosion. But it's a little bit different process than what is done by a river or a stream or normal surface runoff. And let's take a look at that. So here we've got this big chunk of ice and it's moving across the land. And remember, glaciers can be up to a mile thick. So they're big, heavy, slow-moving chunks of ice. And as the glacier moves across the land, it pushes or bulldozes some of the material that it's riding on top of. And what you wind up with is a big pile of stuff. We get stuff that was here that is now here. That's erosion. Remember, erosion is the movement of stuff by water, and a glacier is water. So erosion is the movement of stuff by water or wind with the help of gravity. For glaciers, the gravity comes into play because, you know, glaciers only flow downhill. They don't go uphill. So gravity helps pull the ice downhill, which helps pull the sediments downhill. Now, if the glacier goes away, the ice melts. We can see evidence that, hey, there was some stuff there. There's a big hole in the ground now there, and there's a big pile of stuff over here. So we have some erosion, and then we have some subsequent deposition. Now, how can a glacier cause so much erosion? It's really, really slow-moving water. We know that slow water doesn't cause as much erosion, but the trick is with a glacier, there is a lot of water. And we know that the more water there is, the greater the erosion. So glaciers can cause erosion not because they're fast water, but because there's so much water. So if we look at this picture here, you see this cut in the land that was here. Well, that used to be a solid mountain, but a bunch of the chunk of land that used to be there has been moved. That's erosion. That was caused by the movement of that ice or movement of that water. That's erosion. Now, how does a glacier cause erosion? It's a little bit different than particles of water that push on and roll particles or pick up dirt and carry it with runoff. We have this process called plucking, and this is going to be kind of a multi-step process. But by definition, plucking is the loosening and moving of rocks on the bottom of a glacier. Glaciers only cause erosion basically on their bottoms or on their sides. So what happens is that on the bottom of a glacier, the ice actually isn't frozen. The water is actually liquid. And what happens is the water kind of gets forced into the cracks in the land because this ice up here is so heavy that it pushes this melted water into the cracks or the pores in the ground underneath it. Well, if it gets cold, like it does with the glacier, the water in there then freezes, expands, and breaks the rock into a bunch of little pieces. Then the next year, when the glacier starts flowing again, or we get some melted water, well then all of that loose stuff is then carried along with the ice. This is a process called plucking. Plucking is how a glacier is able to break stuff into small pieces and then move it.
So here we are in Iceland looking at a glacier. And you know what happens. It snows way up there in the mountains, and the snow piles up and makes ice, and it squeezes together, and then gravity pulls it downhill, much like flowing water, except it's frozen water. Well, it's still water moving, and that water moving can cause erosion. It can move stuff. It can move sediments, and glaciers actually do that as they move. They push a large amount of sediments out in front of them. And here you can see examples of the stuff that a glacier moves. Now, this mixture of stuff, and I say mixture because you can see there's a bunch of different things here. There's some dirt in there. There's probably some sand. There's some big rocks. There's small rocks. There's cobble. There's boulders. There's pebbles. This loose mixture of stuff that a glacier pushes out ahead of it, that it moves via erosion, is called till. T-I-L-L. Till is this mixture of stuff that the glacier pushes out ahead of it. And glaciers can push a lot of stuff because it's a lot of water frozen as ice in a glacier. It's not moving fast, but there's a lot of water. Now the glacier for now is way over there. So how did this stuff get way out here? Well, we know that glaciers get bigger and get smaller. And at some point the glacier was bigger and must have pushed out to where I'm standing. And we can tell the glacier came out here because we see this big, huge pile of stuff out here. Even though the glacier isn't out here now, we can tell that this looks like the stuff, the till that glaciers move. These big piles of stuff have a name. They're called a moraine, M-O-R-A-I-N-E. A moraine is a pile of till that was piled up by a glacier. And there's two types. This one here would have been way out at the end of the glacier. That's called a terminal moraine, or terminus, at the end. And that's what tells us how far out the glacier got before it started to recede. You can also have piles of stuff that run beside the glacier, and those are called the lateral. Lateral means aside or beside the glacier. So once again, glaciers can cause erosion. They can move lots of stuff. The stuff that they move is called till, and the piles of that till are called moraines.
Here you can see it in the picture. All this loose dirt over here. That's stuff that was piled up as the glacier was moving across the land. Now, during the last ice ages, there were a lot more glaciers covering North America than there are today. The glaciers were bigger, they covered more area, which means they also caused a lot more erosion. And we can see evidence of this all over the northern United States.
So here I am in a parking lot, and like a lot of parking lots, you'll have these little curved off areas that are filled with rocks. In Georgia, most of these rocks would be pretty uniform. They'd be all granite, so they'd be mostly gray to white in color. But I'm not in Georgia, and this parking lot is located in Minnesota. And I'm in an area that 10,000 years ago was under the last great ice sheets of the last ice age. And when those ice sheets moved across this area, especially coming down from Canada, they brought rocks from a bunch of different places and dropped them here. And we see evidence of that in two things in this picture. One, look how most of the rocks are rounded. This is an indication that these rocks were in some kind of water-borne environment. They've been weathered and rounded and smooth like they were in a river. Just in this case, it was the river or the water associated with a glacier. The other thing you'll notice is the vast difference in appearance among all these rocks. It's not very uniform. We've got some gray ones, we've got some tan ones, we've got some white ones, and that's because when a glacier moves across the land, it picks up lots of different material, and when the glacier stops, it drops it all in one place. That is called glacial till. You can even see it in this rock right here. That's a really big rock, and I'm not anywhere close to a river that could move that rock because the land here is very, very flat. So all of these materials here are glacial till. They are rocks that were moved by a glacier during the last ice age and were deposited here when the glacier melted and went away.
Now, there was a limit as to how far south the glaciers got, and we can actually see exactly how far the glaciers got because we can see where that till is and where it isn't. Long Island, there in New York State, is actually right at the edge of the glacier. Long Island is there because it was where the glacier bulldozed a whole bunch of material and dropped it and left it there. If you fly in a plane over a lot of places in the upper Midwest or New York, you'll see these kind of funky looking little mounds of stuff. Now they're covered with grass and plants now, but those are basically big piles of stuff, sediments that were deposited by the last ice age glaciers. You can see them here. Really weird shape. This is a kind of a teardrop shaped hill because this tells you which direction the glacier was moving. You can see it. Now, it's not just the pile of sediments that the glacier drops can be seen. You can also see, remember, where the stuff came from. Where's the hole in the ground where the glacier moved material?
So here I am in Iceland again, and behind me is a good example of a valley glacier. Now we know these valley glaciers, they move forward and they move backward. And when they move forward and backward, they kind of till up the ground that they're on. And they pick up rocks and they pick up dirt and they bulldoze that stuff forward and backwards. And we can see evidence of that right here in this big rock. See these little lines right here? These are called striations or chatter marks. And this is where that glacier behind us there was bulldozing a bunch of little rocks, and when it slid over the top of this bedrock, it scratched, just like drawing your nails down a chalkboard. And it made these little grooves in the rock. This is one of the ways in which we can tell which direction a glacier is moving or has moved, by the direction of these striations or chatter marks. Once again, these are striations. These are grooves caused in the land or in rock when a glacier scratches it as it moves over the top.
Now, imagine this on a larger scale. You can see here, notice how we've got all these little bumps and grooves in the land. They all seem to be kind of going, looks like they all kind of going the same way, because that tells us which way the glacier was moving. The Finger Lakes region of New York. There are some 11 lakes here in upstate New York, and they all are long and skinny and all face the same way. And that's because the last ice age, the glaciers came down that way and they made scratches in the ground and they made those deep cuts. Well, then the glaciers retreated. They went back and they melted. And when the water melted, it filled up those deep cuts in the ground, and we get these very uniquely shaped lakes called the Finger Lakes in upstate New York. Same case here. This is what's called a hanging valley. There used to be a big, huge glacier right there that came into the even bigger glacier that was moving this way, kind of like a tributary meeting the main river. Well, the glaciers long ago disappeared, but the big cut in the ground where the glacier was is still there, and it's made a valley.
So here I am in Iceland, and if you'll notice this big huge rock here behind me, and something's weird about this rock, and that is that it's out of place. It's this big huge mass of rock, and if you look around the area around me, there are no mountains. There's no rocky area around me. This rock is just sitting out in the middle of the flat, grassy area. Now, we've got a little stream over here behind us, but there's no way that little stream could have moved such a big, large rock. Now, this rock had to have been moved by a glacier, because a glacier is the only thing powerful enough to move a rock this size. So, where's the glacier? Well, the glacier was probably back up there in those mountains, and has long since been gone. The glacier has melted and has receded. But when the glacier was active, it moved this big, huge rock from way up there in the mountains to down here where it shouldn't be. It is out of place. It is erratic. So a big, large boulder that is out of place is called a glacial erratic.
You can see these all over the upper Midwest. You get these kind of big boulders just kind of sitting out in the middle of nowhere where you wouldn't expect to find them. They weren't dug up out of the ground. And notice this one here is pretty rounded, which kind of indicates there was some water in play here. This is in Minnesota, where during the last ice age, this rock here doesn't match the rock in Minnesota. It matches the rock they have in Canada. But when the glacier moved from Canada down to Minnesota, it brought that rock with it. The glacier melted, left the rock behind. That's a glacial erratic. And sometimes they can be really big chunks of rock. You can see them here in this picture right here. It's in the flatland. The glacier was over here somewhere, and it brought that rock out of the mountains and dropped it there. A couple other examples. There's my glacial erratic, and you can still kind of see the glacier way up in there. The glacier brought that rock down to here, then the glacier melted and disappeared. This is in Connecticut, and it's exceptionally flat. It's very close to the shore. But when the glaciers came from the last ice age, they were able to carry big, huge chunks of rock like that. Now they look out of place, because they are. Sometimes when you're digging in the ground, you want to build a house, build a road, you come across these that have been covered up. And this is an example of a 150-ton erratic that had to be moved because they were trying to do some construction. This was in New York City. Here's one in the Midwest, upper Iowa, where they just didn't even bother trying to move it or break it. They just made the street go around it. This is a beach in Long Island. Think about our beaches. We don't usually see rocks on the beaches. We see sand. But Long Island, which was right at the end of where the glacier pushed material, you see these big rocks. You see these erratics that got pushed there because that's as far as the glacier got. Now, where can we find an example of all these glacial things that we're talking about? Only up in the northern part of the United States. We're going to say this area we can call the upper Midwest or the northern United States. Certainly as you go into Canada, you can see it because that's where the glaciers were in the last ice age. Now, there's no glacial erratics in Georgia. We can't find one because there were never any glaciers that came this far south. Now, let's switch to wind. Now, an aeolian process. This is a kind of a catch-all term that describes any activity by the wind. And we're specifically going to talk about erosion, but an aeolian process is something that the wind does. And the wind can pick up and move sediments. The wind can cause erosion. And you can see it here. You can see that dust cloud down in there. You can see all of that material being picked up and moved up into the air by the wind. Well, that's obviously stuff being moved. And it's the wind blowing that stuff around. That's erosion, but this time it's caused by the wind and not by water. So let's talk about the term deflation. Deflation is the fancy term for wind picking up and moving stuff. It's a fancy term for how wind causes erosion. And we can see it here. We can see the winds really blowing it. We can see all of that material that's being blown by the wind. We can see up there at the top of that big huge sand dune, we can see stuff get moved around. There's no water up there. That's obviously the wind that is moving material. The wind is picking up this stuff and moving it around. That's what deflation is. It's a fancy term for erosion caused by the wind. It's the act of the wind picking up stuff and moving it around. Now, how does that wind move the material? There's three ways, and it depends upon the size of the sediment. You get what's called suspension, which is where you get stuff in the air. Think of like being a dust cloud. That's suspension. The stuff's floating up in the air. Now, saltation, we had that with water, and that's where stuff gets bounced along the ground. Finally, we also have this term called creep. Now, creep in this case with the wind has a little bit different meaning. Creep is the action of wind rolling sediments across the surface. And wind can move things any one of those three ways. This is an example of suspension. You can see all of that stuff up there in the air. It's up in the air. It's being suspended in the air because the wind is blowing. That's suspension. This is going to be an example of saltation. The stuff is not coming up high in the air. It's just kind of being rolled and pushed and bounced across the ground. It's not sliding. It's not really rolling, but it's not getting up in the air either. That's saltation. Now, creep is a little bit harder to show you an active example because it happens slowly, a lot like land creep does. But wind can push or roll materials across the ground as well. And this is how wind is able to move big stuff. This is in Death Valley, California. It's the racetrack playa. And this is a place where for years scientists didn't understand and couldn't figure out, well, how are these rocks moving? Because it's not a down slope and there's no flowing water there. What they figured out was that when it does rain and the ground gets a little wet, gets a little slick, the wind blows and can actually slide or roll some of these bigger sediments across the surface. That's called creep, and you can see it right here. Those are all big rocks that were rolled or slid by wind moving the pieces. That's creep in this case. Now, when the wind blows stuff around, remember, wind is going to move stuff. It's going to pick some sediments up and move it somewhere else. It changes what the ground looks like, or it changes what a rock looks like. You can see here, some of those sediments have been removed. They have been eroded. The stuff down here you can see has been eroded. It's gone. The rock isn't uniform anymore. Notice that erosion with the wind tends to happen a little bit more severely lower to the ground. You'll see it in this picture. Notice down here there seems to be a lot more stuff that has been moved because that's where the wind is actually blowing more stuff around. Remember that saltation, it can't get stuff way up in the air. So rocks get sandblasted and they get broken into smaller pieces because the wind is blowing a lot of sediments around down here. You don't get as many sediments blowing up here, so the rock stays its original shape up higher, tends to get eaten up and eroded more down low. These weirdly shaped rocks are called ventifacts. These are rocks that get sculpted or shaped by the wind. Now, where is this wind erosion bad? You'll notice in this map, it seems like it's bad in that middle part of our country, and that is true. The middle part of the country, or what we call the Midwest, is where wind erosion is the worst.
So let's talk about why there's so much wind erosion in that middle part of our country. Well, first and foremost, if you look at this land back here behind me, you can see that it is entirely flat, which when there's nothing to block the wind, either buildings, mountains, trees, the wind can get going and it can pick up speed, therefore it's going to pick up more stuff more easily and cause more wind erosion. Second reason is I'm here in Kansas. In Kansas, in the middle part of the country, way away from the ocean, where you get that mixture of hot and cold air. Things get hot and cold very easily. Well, that makes differences in pressure that are higher and lower, and therefore will cause the pressure differences that give you wind. Now, the third reason, and one of the more important reasons, is look behind me. This land in this part of the country is used for farming, and for a good portion of the year, there is no plants in the fields. Well, without any crops or plants in the fields to hold onto the soil, and you have a lot of wind, you're going to have a lot of wind erosion. So, to summarize, the reason why there is so much wind erosion in the middle part of our country, in the Midwest, is because there's a lot of farms and there's a lot of wind.
So farms have a really big problem with wind erosion because the land tends to be flat and there aren't a lot of plants that cover the ground most of the year. So the wind is able to pick up the sediments and move them. And that's a problem because farmers need their soil to grow their plants. If the wind blows all the soil away, the plants don't grow very well. So wind erosion is a big deal for farmers. Now, here in Georgia, we don't have a big problem with wind erosion for a couple of reasons. Because our land is so covered in plants and trees, and we don't have as much wind because we've got all these hills and trees, and we don't have the extreme temperature changes that cause it to be so windy like it is in Kansas and Nebraska in the middle part of the country. So what can we do to prevent or lessen wind erosion? This is a little bit different than with water because we really can't work much with wind. We can't cause there to be less wind. We can't divert wind and make it go one way or the other. That's not as much an issue. But what we can do is try to lessen how much sediment gets blown around. Farmers will typically do this. They plant rows of trees between their crops, between their fields. And what will happen is as the wind gets blowing, it doesn't go very far before it hits this row of trees. Well, if it hits the row of trees, it's got to slow down and stop a little bit, and it will drop its sediments. So the wind blowing this way hits those trees, slows down. Hits those trees and slows down. And eventually it keeps hitting these rows of trees so that the sediment can't get picked up and moved way away from my field. These patterns of rows of trees in between farmers' fields have a name. They're called a windbreak. A windbreak is a row of trees that are planted to stop the wind from picking up or taking away sediments. Here's a new windbreak. Here's a farmer who's got a field over here, and he has planted all these trees, and they're going to grow big enough that they will stop the wind from blowing too fast across his field and taking his soil away.